All right, problem number 9. We're given a graph of f prime of x, some derivative of a function, and we want to sketch a possible graph of f of x. Notice this says a possible graph because there will be infinitely many solutions here, infinitely many possible graphs that could have that as a derivative. But we do want to show accurately where, in terms of x values, we'll have a relative minimum or maximum values on our function f of x, and also where we will have points of inflection. So things to remember is that anywhere the derivative is 0, that's corresponding to your function having a slope of 0, which means you either have a max or a minimum value. Now remember, the derivative is quite literally telling you the slope of your function. So if you look to the left of that first 0, we can see that the function there is negative, meaning our derivative there is negative, which means our graph has a negative slope. So it has a negative slope there, and then it goes to a positive slope in the middle, and then it's negative again on the other side of that second 0. So think about that. We're going down, then we have a minimum, and then we're going up for this first point right there. So if I'm graphing this, I know that, sorry, I guess I don't really need that. If I'm graphing this, let's make it look like that. Let's say there's our x value of 1, and then in the middle there's 3, so 2, 4, and then 5 right there. We know that we will have a relative minimum value at the x value of 1 right there. And again, it's because our graph is negative there and then positive, means the slope has to be negative and then positive like that, giving us a minimum value. So now the graph's going to come down like that. That's pretty poorly drawn. Let's say it's going to come down something like that, minimum value, and then it's going to start going back up again. Now, this point in the middle where the derivative is 0, if you think about it, our values here are increasing. The derivative is increasing, which means that positive slope is getting bigger and bigger and bigger and bigger, so steeper and steeper and steeper until we hit that spot right there. And then it essentially maxes out its steepness, and it doesn't get any steeper, and then the steepness starts to decrease. And so that's going to give us a point of inflection at that x value, which is 3. So this graph is going to go up steeper, 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 steeper. It's going to hit that x value of 3, and then we're going to get a point of inflection. So it's going to switch concavity and start decreasing its steepness while still increasing its values, because we know over here, although the function, the derivative there is decreasing, it is still positive until we hit the x value of 5 where it's 0, which means we'll have a relative maximum there because it's increasing and then it hits 0 and then it's decreasing because of that negative right there. So over here at the x value of 5, that's where we're going to end up with a relative maximum right there. So it's going to look something like that. Kind of hard to draw, but again, as long as we're lining those values up, I think we're okay. And I'm going to show like x value of 5, x value of 3, x value of 1, and then I would say that this is a pretty gosh darn good looking graph right there. And there should be perfect symmetry there if you look at the fact that this shape right here is a perfect parabola. But there you have it.